Hey folks, Dave Naves here. Wanted to do a final video about my automatic chicken coop door here that I built. It's been taken me a while now, on and off, in between projects, my web projects, all controlled by the Arduino, which some of you probably watching this video already know what that is. For those of you who don't, it's a little microcontroller that you can program for many different things, including many urban homesteading projects, if that's what you want to call this. Anyway, I thought I'd just do this final video to show it installed and working, but I also thought I'd mention why that somebody would want to build an automatic coop door. For those of you who don't have chickens, don't know that chickens come to roost every night, and they need to be safe from predators who want to eat them. So one of the biggest pains of having chickens, not that there's so much pain, but is coming out to open up the door and close it every night. Specifically, if it's too cold out, or say you're going out to dinner and the sun goes down, that's when predators start hunting. So anyway, this having an automatic door is really helpful. Is also because chicken nerds like me love to build stuff like this. So anyway, my entire coop is automated. I'm going to do a video and web pages for each of the pieces that I've built over the past year. It's pretty cool. I'm really happy with the results, and part of why I'm doing the videos is to share. I'm big on sharing. For those who maybe want to take on a project like this, perhaps my code or my diagrams, whatever, will be helpful to you. All I ask is that if you use whatever I've done, which you're more than welcome to, please pay it forward and share with everybody else, including me. I really want to see what other people have done with coops, because that's how I learned. I didn't know anything about the Arduino. I didn't know much about chicken coops and know anything about chickens until I just jumped in and got started. And it's pretty fun. So anyway, I'm going to do this quick test here. The door, the way it works is I have a photocell up above. I'll do a close-up in a minute. A photocell resistor which reads light levels every 15 minutes. I'm sorry, every 10 minutes. For this video, I've changed it to every 10 seconds so you don't have to wait. So I'm just going to take this piece of tape and I'm going to cover it, thereby making it think it's dark out, and the door will come down. What I wanted to show is, and what you'll see in the code, is that there's two sets of reed switches. Reed switches are magnetic. I chose to use reed switches because they're magnetic and they're not mechanical. I thought that maybe over time, switching something on and off every, constantly would possibly break down. So anyway, when it hits a magnetic field, the circuit's closed. So right now, the circuit is closed up here at the top reed switches, telling the Arduino that we're open, it's dangerous, chickens are unsafe, but it's daytime and they're within a giant run here. And I've got it all fenced. So for the most part, they're safe. But at night is when the predators come out again, that the reed switches down here need to, the circuit needs to close and the door will remain closed until it's light enough again. So anyway, I'm going to cover this up. Again, I'll do a close-up of that, but I just covered up the photocell, and within a few seconds the door is going to start closing. There it goes. There's a little motor behind here just attached to a cord that by the weight of itself just drops down, as you see here, and it's going to stop once it hits that magnetic field of the two switches. And there it is. So now the Arduino has been notified that the circuit's closed. Right, the reed switch circuit has been closed, and the door will remain closed if the light level is between 0 and 3, according to the readings that this photocell gives out, and the bottom switch circuit is closed. Now, by me taking this off, again, it's going to be up to 10 seconds, but it's going to read light levels, which are going to be, I believe I set it to over 125 or above, which means it's light out consistently, stays lit, and will again, in normal circumstances, will read it every 10 minutes. And then it will stop up here once that reed switch circuit at the top is closed. So I'm going to peel this off again. Tape's off. And there we go. It took full 10 seconds, I guess. So motor is going in the up direction, right? For those of you who know anything about motors, it's I set it to full 255, value 255. and there it stops because it hit that reed switch circuit again. So I'm going to do a reverse angle of this and show you the inside of what it looks on the inside. Even though it's encased, I'm going to show you the motor, the installation of this photocell encased in an audio casing, right, a 1/4-inch audio plug. Just took the casing out, filled the whole thing with silicone. On the very outside, put on clear plexiglass just to protect it. And then on the outside of the Coop, just put half of a grommet, and so it sticks in there really well. It looks pretty clean, and it will take decent light readings all day long. Okay, wanted to show the reverse angle here, the inside the Coop. There's the door mounted on the inside. Just wanted to show a couple things. If you look closely, the interior here, right there in the middle of the frame, you'll see the one half of the reed switch. There's the cable running up to it. Right, it's got a little paint. I guess it's just been scraped a few times by the door. But anyway, there's the groove, which the door slides up and down. The door is actually behind that casing there. Some chickens want to come in and see what's going on here. The other thing I wanted to show was the reverse angle of the photocell, which is right there. Just poke right through the Coop. Right. Nice cable. We've got some heat shrink on that into the 1/4-inch audio casing that's housing the photocell itself. And I'm going to back off here. There's my cool webcam. And there's a housing for the motor right there. I'll show you real quick. The motor is just sitting inside there. Not a great view of the motor. This is the back side of it, sitting on some angle iron. So the spool is actually pointing away from us, which just is holding the cord that pulls the door up and down. So anyway, we're going to simulate night right now. Go ahead, son. My son's going to put tape over the photocell resistor, simulating darkness, and there goes the door. If you look closely on that door, that little line right there is the other half of the reed switch. It's going to go all the way down until the door closes all the way, hits the reed switch, and boom, it stops. One thing I wanted to show right here, I put two 2x2s right there on an angle, so that if the chickens kick all their dust on it, it won't block the door, right? So that the what do you call it? The shavings will just fall off to the side. So as you can see, they're already pretty clean. So anyway, we'll pull the tape off, and you will see that the door will come up again. Right? It thinks it's light outside, which it is. And it's going to go all the way up again until it hits that second set of reed switches. And it's done. So that's all I really wanted to show, the whole thing working and why I built it. And again, I hope this video and the whole web page illustrating how I built it and what parts I used was helpful to you. Just again, if you're going to use any of it, just pay it forward. Let me know what you're doing. If you have any questions, hit me below in the comments area. I'm happy to answer any questions, and hopefully this will save you some time if you're going to get into building a chicken coop door and the rest of perhaps even a fully automated coop like me. Okay? Take care.